Hey everybody, it's Mr. Clausen here. Just wanted to show you how to do LoggerPro round 2, specifically how to straighten a curve of graph. So this is the same data from the previous video we had. This is the graph down here that we were taking a look at that no longer looks like it is a straight line. So we wanted to take a look at this. So once again, this definitely appears to be a curve. Just to make sure, if I go ahead and I put a linear fit on there, you can see a straight line that doesn't seem appropriate. We're curving down here, we're below it, and then up here we're above the line. So what you would do in this case to find the mathematical model, because it's not going to be a linear straight fit, you got to go back to that chart I had you put in your notebooks. So you go ahead and find it in your notebook, and you'd scroll down here, and you'd see number 4 is the shape that appears to be what we're dealing with. So it seems to curve up, just like this one is. And so what we're leaning towards here is this would be a squared relationship. But we're not exactly sure, because it could also be cubed or to the 4th power, some weird random number at that. So we just want to double check to see if it's actually a square, and that's what curve straightening is all about. It's just the double check. So what we're supposed to do according to the chart is we are supposed to plot whatever's on the y, we keep on the y, and this time what you do is you just take all the things that you have on the x-axis and square them according to the notebook that we had there for number 4. So you have a couple different options. One you could do is you could just come down here and you could do new manual column. And what that would do over here in your data set is it would just create another column, and you could go ahead and type in the values just like you always did. So what you'd have to do is bring up your calculator, all right, and then you would take all the ones that were on the x-axis and you'd punch them in. So for example, if you don't know what 3 squared is, you'd come over to the calculator, you'd hit 3 squared, and it would tell you that's 9, and you would type that into the column. Now, this is okay, and it can work. I mean, it's totally fine. It's up to you, but there's a way that I like to do, because I don't like to do a lot of calculations if I don't have to, and that's to get the computer to do the work for me. So we come up here to data, and what we do is we say we want a new calculated column. All right, so it's going to ask you for some stuff here. It's going to say, what's the name of the new column? So I'm going to call it time squared, because the reason I picked time is because on the x-axis down here it was time. The new variable short name would be t, and I'm going to use a superscript 2 to represent squared, and then the units would be seconds, superscript squared. Okay, now it's going to ask for the expression. So you might be tempted to just write time squared, but if you did this, it wouldn't quite work out because it doesn't know what column that is on the computer. So the best way to do it is just come down here to this part that says variables or columns and select the column you want it to actually do the calculations with. So for us down here, it says time. So what we're going to want to do is use the time column. You put that in, it puts it in quotations there. I say to the caret second power. I hit done, and what that should do for us is it created a new column of time squared. So all we have to do now is insert a new graph and get that graphed for us. So I got that graph. We're going to click on the axes to make sure we're getting the right ones here. We don't want it from data set 1. Remember, that was the one we did before. This one here is from data set round 2. So we're going to say, please put distance on the y-axis. Okay, so that's all good. And then this time, what we want to do is put time squared. So I clicked on that. It brings up time squared, and that's the one we want to pick. You do that, you can already see right now we have a nice straight line. At least it appears to be straight. So once again, we're going to want to check this just to make sure, because it's all about double checking. It's not like you have to do a bunch of extra steps. Just hit the linear fit line, and what you do is you can see that right there that we have a nice, much higher correlation than we had before, 0.99999. It doesn't get much better than that. Okay, last thing you're going to have to do is you're going to have to decide if this y-intercept matters. So what this means for us is, how do you take this and then come up with a mathematical relationship? So what I want to do is just bring up a little text box here for me so I can type in there for you to see what's going on. So what you would do is, in your notebook, what do you actually write down? So when I ask for the equation for the line, it's going to be y equals mx plus b. All right? So in this case, what would you actually write down? Well, it's not y in this case. In this case, what we actually want is distance. So you'd write distance equals, and then the slope is what m is. We don't really care about m, so you put in the actual number. So the slope in this case would put 0.9969, and then put in the units as stated. You put that in parentheses, so there's our m. And our x in this case would be time to the second power. And then the b, we have to decide. So does this b much matter here for us? Does this y-intercept matter? Or is it so close to 0 that we can just call it a 0? This is where you'd implement the 5% rule. And so the 5% rule says, is the y-intercept within 5% of the total range of values. So if you take a look here, our y-axis goes all the way up to 109. 0.1342 is going to be much lower than 5%. And since it is lower than 5% and we have a reason for why it should be 0, we're not going to head and just not include that on there. That 0.134 is just showing up as experimental error and the computer's calculating it out. All right, so that's how you do it. So in this case, this would be the mathematical model for our relationship here. And we got that from the graph. We know that the curve that we saw before, this one back here, is going to be a y versus x squared relationship. Hope that's it.